Okay, today we're going to be simplifying rational expressions. I'll do a couple easy ones for you and a couple harder ones. So the way I like to think of it is you have numbers and you have variables, and they're kind of like oil and water. They can't mix. You have to treat them separately and work with them separately. So for this problem that we're starting with here, we have our numbers, negative 36 and 42. And I'll make that a little prettier. Negative 36 and 42, but we also have our variables. So we're going to sort of keep them like separate thoughts in our mind. So first, we need to ask ourselves if we simply had the fraction 36 over 42, how would we simplify it? What is it that goes into both 36 and 42? Well, I'm noticing 6 goes into both. So we could simplify this fraction down into 6 over 7. So now we can say, is that numerical fraction as simple as it can get? And it looks to me like it is. So now we're done with the numbers and we can move on to our x to the third over x squared. And another way to think about this is you could say x to the third is 6 times x times x times x. And another way to think of our Another way to think of our 7x squared is 7 times x times x. Now we know on a fraction, if everything's being multiplied, we can cross things out on the top and bottom. So we could cross out this x with this x, because there's one on top, one on bottom. We could cross out this x with this x. And what would we be left with? We would have our 6 over 7. And what's left in terms of x's? We have one x on top. So that x remains on top. And this would be your final simplified version. Okay, let's do number 3 here. 16p squared over 28p. So what is it that goes into both 16 and 28? Well, I know the number 4 goes into both. So what if we divided both the top and bottom by 4? Well, that would give us 4 on the top and 7 on the bottom. We know 7's a prime number, so 7 cannot be simplified any further. And now we have p times p over p, right? P squared is p times p. We can cross out 1p on the bottom with 1p on the top. So now we get 4 and 1p remaining on top over 7. Another way I like to think about these, looking at the original problem here, when you have variables like p, you can assume there's a 1 here. That's p to the 1. So we ask ourselves, who's winning, the top or the bottom, in terms of the p's? We have a 2 and we have a 1. Who's winning, the top or the bottom? The top. How many is the top winning by? Well, the top is winning by 1. So there will be p to the 1 remaining on top. Right? We just don't really need that p to the 1, but we can think of that as p to the 1. So let's do a couple harder ones. All right, so now we have 2r minus 4, two terms on top and two terms on bottom. Whenever you get this, you want to be asking yourself, wouldn't it be nice if we had an r minus 2 on top and then we could cancel it out with the bottom? So now we have to factor the top. We have to ask ourselves, what can go into both 2r and negative 4? What number can go into both of those? Well, that would be a 2 because 2 goes into 2r and 2 goes into negative 4. And then we have to ask ourselves, well, we factored out a 2. If we were to do distribution, what is it that we would have to put in this spot and this spot so that we would get these terms back, right? If we wanted it to be the same, we want to be able to put something inside there. So if we were to distribute it, we would get our original back. So let's see, what can we multiply 2 by? What can we multiply 2 by to get 2r? Well, 2 times r is 2r. What can we multiply 2 by to get -4? Well, we can multiply it by -2, right? And just to prove this, if we were to distribute this, 2 times r is 2r, and 2 times -2 is -4, right? So we would get these original, it is the same value. So we're just representing it differently. That's just a little side quest there to show you how factoring works and why it works. But now we know that this value, 2 times r minus 2, is the same thing as 2r minus 4. And we know that we have an r minus 2 on the bottom. I can put parentheses around it, knowing that now we can cross out this whole parenthesis with this whole parenthesis, and the only thing remaining is a +2. Let's do one more. Now this one involves a little quadratics, it looks like. So we know we have our x minus 4 on top, and wouldn't it be nice if there was somehow an x minus 4 on bottom? And that might give you a hint as to how you're going to factor out here. So we have a -12x and a 3x squared. What is something common that goes into both of those? Well, I know that 3 goes into both 3 and -12, and I notice that both of them have at least one x. So we can definitely pull out a 3x because 3x goes into both 3x squared and -12x. So now what do we have to multiply 3x by to get 3x squared back? 3 times what equals 3x squared? Well, 3x times x equals 3x squared. So if we were to distribute this, the first thing we would get is 3x squared. That's where we came from. So now what do we have to multiply 3x by to get -12x? Well, we have to multiply -4. -4 times 3x is -12, right? So if we were to distribute this out, we would get our original 3x squared minus 12x back. So isn't that convenient? Now we have an x minus 4 on the top and an x minus 4 on the bottom. We can cross those out. So we're left with a 3x on the bottom. A lot of students ask, what do I do when I've canceled everything out of the top, right? We can't put a 0 because that wouldn't make any sense. So we leave a 1 as a placeholder here. And your final answer would be 1 over 3x.